Problem 21. Which of the following species can be Bronsted-Lowry acids? And we're given 6 formulas to look at. A Bronsted acid, we know, donates protons, H plus ions, in a neutralization reaction. And part of that tells us that they have to contain a hydrogen to donate, an acidic hydrogen, meaning it's one that's being donated. The first formula, HBr, that's hydrobromic acid. Let me blow this up a little bit. Hydrobromic acid. I don't know if you can read that. It was in the textbook. It's mentioned in the textbook. This is one of the Bronsted-Lowry acids, and it does have an acidic hydrogen right here. So what happens is HBr will produce its proton, leaving the bromide ion behind. And this is how it works in a neutralization reaction. Suppose you have a base, a strong base hydroxide ion. And so here's your HBr. It's in solution, and the hydroxide ion is in solution. They come in contact with one another, and the proton is donated over to the hydroxide. That turns hydroxide into water, and the bromide is left behind. The second one is Br2, that does not even have an acidic hydrogen, so I would say no, not a Bronsted-Lowry acid. Neither does the third one, aluminum chloride. There's no acidic hydrogen here. Now, aluminum chloride's kind of interesting compound. It does have some acidic tendencies, and organic chemists can use this as an acid, but not as a Bronsted-Lowry acid. There's another class of acids we haven't talked about called Lewis acids. But anyway, that's way outside of our scope at the moment. So no acidic hydrogen. The third one is formic acid, HCOOH, formic acid. There are 2 hydrogens here. It's the one on the right, which is the acidic one. So here's the Lewis structure, and that's the acidic hydrogen. Hydrogens that are attached to carbon atoms, these bonds are very difficult to break. So hydrogens attached to carbons are not acidic. But the hydrogens that you find attached to oxygen or nitrogen atoms are much easier to come off, and so those can be acidic hydrogens. And so this is formic acid. This is a carboxylic acid, by the way, where you have this carbon COOH. Okay, you'll see lots of carboxylic acids, and they're all different depending on what is over here. So this is simply a hydrogen. So this is, you could say, the smallest carboxylic acid, but other carboxylic acids, you can have larger groups attached to this carbon. The next one is not, no acidic hydrogen here. This is the nitrite ion. The last one, yes. This is nitrous acid. And in fact, if nitrous acid loses its acidic hydrogen, you would be left with nitrite.